Hey everyone, I'm Michael Hall.
And I'm Robert Wolf, and welcome to Innovation Coffee, brought to you by ARM. Michael and I are your hosts this week and every week as we take a deeper look at the ARM developer ecosystem and explore the many things going on in and around this special and exciting space. Each of these live streams may start with developer updates, followed by in-depth conversations about ARM and our growing developer ecosystem, joined by featured ARM experts and partners within and within ARM, and sometimes our community of partners. We discuss a plethora of topics tailored for developers, showcase opportunities, explore resources, and bring new and exciting ARM developments to light. Each of these events will be finished with an audience Q&A. This is from our YouTube comment section or chat. And of course, if you have any questions, make sure you post them in that chat. So that's a good reminder. Now, I'm not sure, Mike, if I like reading off the teleprompter for those intros or if I just kind of ad hocking it. I kind of feel like the teleprompter is not as fun.
You sounded great.
Yeah. Oh, okay, good. Yeah. So if you do have questions throughout the hour, please feel free to put those into the chat, and we'll get to them as soon as possible. These questions could be for our guest, who is a very important and fun guest who we have on today, or it can be for Michael and I, and we can get those questions answered for you. Now, also, if you enjoy the show, make sure you hit that like button, and don't forget to subscribe to the ARM Software Developer YouTube channel, because we do this every single week at 5 p.m. UTC. Michael and I are here bringing you some really cool topics and fun people to talk with about ARM. So Michael, I think before we dive in, did you want to do I think this is just becoming a tradition now. What happened last week, man?
Speaking of fun topics and guests, last week we had Liam Randall and Bailey Hayes from Cosmonic on to talk a little bit about Cosmonic, but we ended up mostly talking about WebAssembly, kind of, how it got started, where it is now, how you can use it on ARM devices, and just all the different potential that it has. And I know for me personally, I didn't know too much about WebAssembly before that episode, but I really came out of it feeling like we got a crash course in that technology, right?
So, oh, yeah, big time.
Great episode. Go back and watch that. And we got another great episode coming up today, don't we?
Of course, yes. So today we are joined by Josef Holzmayr, and he is head of developer relations at Mender. And so we're going to be talking about Mender on ARM. So Josef, how are you today? Welcome to the call.
I'm fine. Thanks for having me, Robert. Hi, Michael.
This is awesome.
And glad to be here.
Awesome. Where are you joining us from, by the way? Is it early, late for you?
I like 1 hour older than you. So
1 hour.
I'm on. It's 6 p.m. for me here. I'm sitting a little bit north of Munich, southern Germany.
You are actually then 9 hours older than me because I'm in San Diego in California on the West Coast. So yeah, you're about to have dinner. I still haven't had breakfast.
And it's getting on to lunchtime for me, so we're all spread out, aren't we?
Yeah. Cool. So yeah, welcome to Innovation Coffee. Usually the way we like to start these calls is to kind of get to know you, right? I think people watching know who Michael and I are. So who is Josef Holzmayr, and what do you do?
Okay, so I'm like a grumpy old man, I usually say, because I've been doing this stuff for a long time. And as we just thought a little bit about it, I actually started out with ARM. So my whole story of doing this stuff starts out with ARM basically 20 years back, when ARM 7s and ARM 9s just were getting into the microcontroller space. I was just finishing my master's, and I started working at a company that was just doing the first ARM-based devices. And yeah, long story short, from there on, I grew into embedded Linux, I grew into Buildroot, into the Yocto project, and I kind of outgrew the actual technology, because I found that talking to people and making cool stuff and showing others how to reach their goals in making the stuff that makes our life better is actually what I want to do. And that's why sometime back, 2 years, I think by now, I decided, okay, I've had enough industrial controls, like pumping sewage or heating rooms and compressing air for one lifetime. And I joined Mender, where I'm now talking to lovely people like you before I'm heading up for dinner.
We try.
It is a fun transition, though, from being deep in the tech, being a programmer, to talking to people about it, isn't it? I made a similar transition myself more than a few years ago, but back when I was at Canonical, from working on developing Ubuntu to being an advocate and a community person for the Ubuntu project. But it's a whole lot of fun to be able to do that now, isn't it?
Mm-hmm. Actually, I transitioned the really long story from being a certified electrician. So I mean, I've been really chopping up walls and running cables and everything.
Robert, that's your background, isn't it?
Running cables?
Not running cables, but you were electrical engineer, right?
Yes. So I studied electrical engineering, and it's surprising because I feel that a lot of the things they teach you in engineering, or at least electrical engineering from my experience, didn't really get applied to my day job. I feel like I had to just the jobs that I've had so far, every single time I've had to basically learn a new thing. And I'm not, crunching digital signals. I mean, like I did digital signal processing. I'm not diving into DSPs and modifying frequencies. I'm not doing anything like that. I've never done anything like that. So the most thing I think I ended up doing was just working with single board computers, hacking away at things like that. My electrical engineering career didn't come much into play. Also, all that mathematics, like, I mean, what was that for?
Yeah. So you actually learned the stuff that I wish I had have learned at university. So I always wanted to do the DSPs, and I learned the boring stuff, like all the maths and literally mounting wall plugs. But I could put quite a bit of that into real usage. So I've actually routed schematics, and I've built single board computers myself. Back in the day, not anymore. I've got some
you got all the tools back there.
Stuff over there. Yeah. Let's say my professional experience is a little bit long-winded.
I say one of the most fun things that I think I built, it was actually with our producer here, Gabe. It was I really enjoy building solar powered systems. So, taking solar panels, taking your charge controller, taking your inverter, building out battery banks, like we built out like battery banks with 3D printed molds and all this kind of stuff. That was actually a lot of fun. And I did have to bring my electrical engineering knowledge into that. But yeah, I mean, I guess I do enjoy the math. So I was making fun of it, but I did enjoy it. So Josef, thanks for letting us get to know you. It's very nice to meet you here, especially on Innovation Coffee. And I think the main reason we are here is to talk about Mender. And I see you got your nice Mender shirt on, it looks like. So the first question I think we should ask here is, what is Mender? And, you're going to be talking about Mender OTA, over the air services. I thought maybe we could also kind of define what it means to be an OTA service. So what is Mender, and what does it mean to be someone who's, people might not know what over the air means, right? So like over the air software updates, could you maybe just kind of define that a little bit too?
Yeah, of course, man. So I personally, I don't like the term OTA first, but it's an industrial term, so I have to go with it because I mean, reality has that most over the air actually goes through a wire, which is kind of like just ruining the term for me. I usually say we are a software logistics company because that's what OTA actually is about. It takes something that is a form of software, really doesn't matter what kind of software it is, as long as it's in some digital form. And we take it from here to there. And there usually is something really remote. That's the thing that sets OTA apart from, let's say, infrastructure management, as you do in the public cloud or your data center, whatever. There you have all these fancy infrastructure as a code tools, and everything is as a big iron switch, and there you can move everything basically instantly. And OTA usually refers to the kind of software logistics where you have a lot of devices out in the field, somewhere in your basement, somewhere on an autonomous vehicle, somewhere in industrial, whatever. And you just mentioned building something solar powered. And I mean, that's like a classic use case for us. Anything that moves out somewhere in the field, nothing works without electronics now anymore. And all of that stuff has firmware in there somewhere. So if I have to like do OTA in 10 words, then it is putting software into all of those devices that are around us.
Yeah, one of the big things I always like to think about, right, is a pipeline. like, let's just imagine a pipeline going from the west of the United States to the east of the United States. And this pipeline needs to be monitored in some way. Has there been a crack? Is there a leakage? It could be gas lines. You just never know. And you have these devices, possibly thousands or tens of thousands of these devices that are laced along this pipeline, monitoring this pipeline. Now, what happens when that device becomes out of date? Now, you have to review whether or not because of this device is out of date, are we, compromising the integrity of this system that we have going? Could there be a gas leakage at which point we are not able to track anymore and someone could get hurt or people could die? And so, traditionally, you program a Raspberry Pi or one of these 96 boards, or you plug into the UART and you have to go in there and modify all of your stuff manually. You have to be physically attached to the device. Now, with OTA, you can update thousands of devices from what I understand at the same time. And so this is huge in terms of saving manpower, in terms of saving, costs, in terms of just simply making the process more efficient. Right. I mean, like,
It really is about that, because I mean, the scale factor sounds a little bit strange sometimes. I mean, how many oil pipelines are there? Fun digression for one sentence. Those are actually monitored from the inside sometimes, and I know people who build those devices and they run Linux on ARM, and I'm not kidding you. But actually, oil pipelines they have a couple of hundreds or maybe thousands of devices, but OTA goes way beyond that, because it's both huge fleets. Think about about TV sets or mobile phones; those go into millions. And if you think about devices that are more complex, like autonomous vehicles, they sometimes are just one entity, but they have 100 of subcontrollers in there. So if I say we're putting the software into devices, then I'm obviously oversimplifying the challenge that the devices often impose upon us. Because the times when a device was super simple, like that one ARM7 I had 20 years back, those times are long gone. And I think the big one thing that makes Mender special in this case is that we are an open source end-to-end over-the-air solution. Because yes, it is the devices and getting all the stuff on the devices sorted out, but it is also the backend about it. You just mentioned it is huge. It is a number of devices, a big number of devices, and all of those devices have to go somewhere and have to be managed from somewhere. And this is the one thing that sets Mender apart, that it does not give you the stuff that is on the device. It also gives you the management backend for it.
Very nice. Very nice. Michael, did you want to bring in one of your questions here?
Yeah. So we were talking about, how these devices can be remote or hard to get to. And a common problem for a lot of these IoT devices, especially when they're in these far-flung places, is internet connectivity. How do you update them if they're not connected to the internet, or they don't have a reliable internet connection? So the question really is, how does Mender handle the intermittentness, the latency, the very low bandwidth that you get when you've got IoT devices out on pipelines? Or one of my favorite examples is out on these wind turbines, where you can't just go walk out there and do something with them. You got to get somebody who can climb up to the top of this to even access the hardware. So how do you handle the connectivity problems that are kind of inherent with the IoT device updates?
So the first and foremost, obviously, is caching and resuming if something goes wrong along or interrupts the fetching of software. But the wind turbines, as you just mentioned, they are actually not the very interesting ones, because a wind turbine is usually stationary and you can adjust to it. So I haven't built wind turbines personally, but I would expect them to have a relatively stable mobile connection or a satellite uplink. And it won't change quite a bit, because there will nobody be coming by and just plugging an Ethernet cable into the wind turbine. But think about you're already on the sea. And think about boats, for example. And those really have challenging connectivity issues, because if they are somewhere out on the boat, somewhere out on the sea, you have satellite uplink that works, but it's super expensive. You really don't want to run any big updates over those. Then if you come closer to the coast, you might get mobile or 5G nowadays, which is okay-ish, but still not super fast. And if they are in dock, then they obviously have Wi-Fi or even a wired connection. This is where you usually wanna do your software maintenance. And the key here is to make the client that is running on the device aware of the circumstances, so that it's not blindly doing whatever it wants to do. So, but that you can tell it, okay, now you can download, now you cannot. Now you are allowed to check on a rapid pace, like 2 or 3 times a day. Now, please really check only once a week and only apply super urgent stuff, or do not check at all, because the download will cost me like $1,000. And the key here is to expose interaction and control facilities, not only for the backend where the developer would push their software. It only means you have to expose those control mechanisms on the device, because all devices are a lot of devices are similar, but each is in a special situation, and each device has to adjust to that situation.
You just made me think of something here. And thank you for the answer, by the way, Michael. Did that answer your question?
It did, yes. Well, one
Okay.
of them, not more.
Yeah. Yeah. So you made me kind of think of something here. You mentioned boats, and boats. Not everyone has boats, but a lot of people have cars, and
Yes.
this whole cars now have like tons of chips in them, right? And these chips do go out of date. There are updates now. Cars are connected, to the web. I'm kind of curious, like, how is this? How is Mender working? In terms of the what would we call the smart vehicle movement? Is Mender working with any vehicles? Are you testing anything out with any of these automated vehicles? Are there any challenges that are being faced in kind of trying to get into this space? I'm kind of curious. What does OTA look like, or what does Mender look like in the automotive space?
So automotive space has traditionally been a challenge for us. I'll be very honest here.
It's a
Because
challenge for a lot of people, though. It's a challenge for a lot of people.
Okay,
Yeah.
that's true.
Yeah.
But so I already mentioned I'm coming from southern Germany, and a lot of people associate this area where I'm working or where I'm living with BMW and with Audi. And Germany, and especially my area, has a very long tradition with that kind of automotive stuff, and they have a very old school engineering approach. So this is why Tesla probably is eating their cake. But the challenges that they face is that they have a lot of variants. That okay, this is where my where my English goes off.
Give it a shot.
Variants?
Variants.
Okay, thanks. Yeah. So when we talk to them, you wouldn't believe it. They actually tell us, okay, we can build these 10,000 variants of that specific car, and we want you to generate an update package for just that one car on the fly when it's garaged. And we're like, okay, that is a challenge. And because it's like the current state of the car, the number of subcontrollers, the state of the subcontrollers, sometimes you are not allowed to update them when they're garaged. Sometimes you are just update to allow them when the car is actually like standing flat. Sometimes, so there's all kinds of site conditions, and pairing that with the huge number of subcontrollers in there, orchestrating all of those in the right order and rolling them back as needed if something goes wrong, which obviously happens too. I think that is the really big challenge in the automotive space, because the combinatorial explosion is bigger there than anything else that I've ever seen before.
Awesome. Yeah, no, thank you. I know Mike's hopping in here in a second, but I also want to, I can imagine the safety issues are also a big thing, right? Like, you can't just like update something willy-nilly. You probably have to get a bunch of reviews on everything that goes into a vehicle. Something is bust in car crash. Yeah.
Yeah.
So-
Michael or?
Oh yeah, Michael.
Yeah, I'm glad we started talking about cars because I saw something recently where I'm not going to mention the car company, but there was an update that was trying to be applied to the car's software system. I don't know which part, but the update failed. And so the car owner got a message saying they've got to take the car into a dealership to get it fixed because of a software over-the-air update that failed. But that's a fact of life. Software fails sometimes. So how does Mender handle that if you push out an update to your devices and that update has a bug that stops the device from functioning properly?
Is this like a brick, like if it gets bricked or something, or the device?
Yep. We don't want cars that are as useful as bricks unless we want to build houses out of bricks, right? Yeah. I think we saw the same LinkedIn post. And yeah, the story here is about the AB approach. And AB means you have two partitions, A, B, or active, inactive, or last and current. You can name them whatever you want. The story is that the software that is currently in effect is running from the so-called active partition. And when a new revision comes in, it is put onto the currently inactive partition. So with all the safety nets in place, all checksum signatures, whatever's are done, it is put in there. And then at the next suitable point in time, not when the car is like moving or whatever, but it's garage, it's turned off, then you do a reboot. And here's the trick: the bootloader or the boot chain has to be aware of the update. That's why the client infrastructure that put the software on the inactive partition needs to set a marker for the next boot process. It comes up and says, hey, cool, there's new software. I got to flip partitions. It goes into the updated partition, starts it off, and if something goes wrong, like it doesn't boot or it doesn't reach any check state or whatever you can define as a good condition, if that is not reached, usually either a watchdog would kick in or a frustrated user would just like try turning it off and on again. And as we all say, have you tried turning it off and on again? That actually will do the magic, because if you turn it off and on after an update and on a rapid pace, I mean, that usually happens just if something is not working as intended. And now the bootloader will say, hey, I just flipped into the new software, but I didn't get a commit for it, like an ACK, but the user tried to turn me off and on again. So something must be wrong. I'm going to roll back. I'm going to the previously active partition because I haven't touched that. It's still intact. It's still known, good, and working. I'm going to set my fail marker, go back, be non-bricked. User can continue, and whatever infrastructure or GUI is on it can then say, oh, update failed. Maybe try again at the next convenient point in time. But for now, we're going to stick with the old one. You can still go and buy your groceries.
Very nice. It reminds me of the multiple redundancies in, like, airplanes and their sensory systems. Pretty cool. Yeah, my car, like I've left my car on. It's one of those push button start cars, and I've left my car on and walked away and forgot about it. And then it runs out of gas. And then when it runs out of gas, then the battery depletes, and I have to go get it serviced. They have to literally replace my battery every time. I've done that. My mom did it once, and I did it twice.
Wow.
Yeah. So like, just they have to go and manually do something to fix it in terms of it not being, you won't be able to use it anymore. Cool. Michael, any more? Cause I want to start talking about, Mender on ARM. if that's okay.
Yeah, we'll go ahead and do that.
So there's kind of two parts here. You of course, Mender, offer various services, for your customers. And so you have your own kind of infrastructure and the likes, right? So I guess from what we were talking about in the green room before the show started, it sounds like Mender has recently or at some point migrated to ARM-based instances. I'm kind of wondering if you have any insights in terms of how that process went for you guys. We've talked to other folks, other partners, ARM partners who have since migrated, from x86 over to ARM, and cost savings in terms of performance. I'm wondering what kind of experience has Mender had so far, and also maybe you could talk about a little bit about what your infrastructure looks like, if you're okay with that.
Yeah, sure. So I already mentioned that we also offer the backend management for all of these devices that we just discussed. And traditionally, we've been running on Kubernetes clusters somewhere in the public cloud, or allowed our customers to run on their own Kubernetes stuff. But so far, it has always been x86. And the Mender software to be used in such cases is a bunch of Dockerized microservices. So far, so good. Which means in the end, we are building containers and shipping them out. It sounds like it's really easy to flick the switch on it, to say, okay, now Docker just build-X it for another architecture, which in this case would be ARM 64. And yes, that's what we did. So surprise story, that actually worked pretty well. Migration done in 5 minutes. Yes and no. Because it is really easy if you're doing something in your basement like me. You just say, okay, now I'm gonna unplug the box and set up the new one, and I'm gonna manually install everything, and then be fine. It does not work like this if you have a history with your software, and if you have a service that you need to keep online all of the time. Because we can just say, okay, now we're going to spin down our hosted offer for a couple of days and see how the migration goes. This is not how things work in the real life. So I have to say, if your software in itself is properly constructed, the migration of the software to run on ARM is really painless. The challenge lies in the infrastructure, or in the code around your code, where you might have accumulated technical debt without actually knowing it. Because when you create software, then you make up your build infrastructure on the fly, usually. I mean, some really big and well-architected projects maybe are immune to that, but in my experience, developers make up stuff as they need it. So that's why we have makefiles, and why we have auto tools, and why we have CMake, and why we have Meson and everything. You always pile on top until it works again for you. And build pipelines and QA pipelines, they often have places where they are just written for one architecture. And you can just flick it out and say, okay, now I'm building for a different one. No, you have to make it aware that you are now building and testing not one, but two architectures. And I think that is the real challenge that an actually production grade software faces if they are doing the switch to or the extension from x86 to ARM, because you can't just throw away x86 in reality yet. So all of your code has to, and your process have to adjust to be aware of it. And so does your SRE team that actually manages all of that. But if you do it, you are rewarded, because both our on-prem customers are now able to run on their ARM 64 instances as they choose. And we've moved to Gravitons, basically. And we've seen a nice cost savings effect just from being more efficient here. I don't have any exact numbers. I mean, you know how people are when it comes to money, but I'd say it's definitely in the substantial 2-digit range, give or take. So like 20, 25, 30%, depending on your actual workload and your data transfers. I guess that's what you can achieve just by doing the work once and making sure all of your stuff is migrated over to ARM. And fun fact, the ones that are running our self-hosted small scale stuff, they cannot do so on the Raspberry Pi, which is kind of like super cool for me to just carry it around, having a Mender backend in my pocket.
That is cool. So I don't know how much you can tell us about how the Mender backend, the software itself is developed, but could you tell us a little bit about what was the process of migrating to ARM like for you? Were there difficulties? Were there dependencies that you needed to work around, or was it just like you target a new architecture and everything goes swimmingly? Because we get kind of both stories sometimes.
Yep. The Mender backend is written in Go, and it has some dependencies like Mongo, for example, or Nats. But I would say that the story that for the core code I'm leaning to is definitely went really smoothly. It's for just building. As far as I know, they flicked the switch and said, okay, now I want to have the container for ARM64 too. The challenge is to make the rest of the stuff aware, and also taking it out to the users, because yes, there is just the core backend, but there are also sometimes services around that. And if those are not tested and executed as regularly, or just are used internally, then this is where I actually can see the pains sometimes. But our experience is that just taking a workload in itself, if it's properly containerized, then it is not a problem. If you have to rebuild stuff from pure source without the Docker pipeline around it, and that's what I do in the ARM world or in the Yocto world more often, then you can hit some really, let's say, nasty effects. We were lucky to not have them on the back end.
That's always good to hear.
We do have a question that came in from the community, and this is from, and I'm sorry, Mo, if I get your last name wrong here, but Mo Alguare, and he's asking if the system is compliant with industry standards and regulations like GDPR, HIPAA, etc. And I made sure to clarify, if he means by the system, he means Mender. So is Mender compliant with industry standards and regulations?
The question is twofold, because if you are self-hosting, which you probably want to be if you are working with systems as sensible to those regulations, then the answer is it depends on your process. Because, I mean, Mender does not move any of your customer data out or whatever. And while technically you can use Mender to move personally identifiable data. I mean, in the end, it's just another binary thing. I would say its prime use case is moving actually software and application software, and so I don't really see where the intersection here is. So let me word it like that. We have customers who work in medical, who are in Europe. That's why we also have a Europe hosting for GDPR regulations or whatever. And the answer is, if you want to use our hosted offering, then Maybe yes, maybe not. It will depend on your actual regulations to apply. If you are self-hosting, like it's running on your infrastructure, then whatever certification or regulation you can apply to it should apply, because it's not randomly moving data out. It's just there. We don't have a magical sink or wormhole that will tell us what to do.
So maybe those two examples are not the best, but what about things like ensuring that the updates you're sending out are, not modified by a middleman or anything like that? Do you do encryption or signing of updates to verify that they're, not been tampered with or corrupted in any way?
Yeah, I think that's the side of the story that applies a whole lot more. And yes, we do apply transport encryption, because a lot let me look at the clock. Half an hour ago, we were talking about connectivity, and what I forgot to mention there is Mender just works if you can give it an HTTPS connection, and that already gives you the story here. HTTPS gives you authentication and gives you encryption. So that's the core layer. The device is authenticated against the backend, and it's got a secure communication channel to where the software is stored. On top, because the storage is something that the backend manages, obviously, and if it's hosted, then you have to trust us. On top, you can also sign your payload that you want to ship out. We support on-site encryption, so it's basically PKCS 11, whatever you want to use there. You can plug it in, and you can sign the artifact and then upload it. Mind, this is a key point here. You have to do it yourself, because if we could sign your artifact somewhere, then you would have to trust us to not abuse this power. And we always tell our users, no, we cannot sign your artifact. It does not work somehow magically in the cloud. You have to do it on site, because only then we can guarantee that we have no chance of modifying your stuff. For that, the usual signage mechanisms apply, like local keys. We also support remote signing through a number of technologies, offers, however you want to call them. And from there on, the signed artifact goes its route to the device where the signature is verified, and if it does not match, is corrupted, whatever, then the artifact is obviously disposed and not applied. So for there, yes, integrity and authentication of the device are guaranteed.
Awesome. Well, we have a lot of questions coming in.
Yeah, they just keep flowing in here.
Aren't we?
I think Mo started something here.
That's okay.
Yeah. Do you want to take the next one? We got Mo here with how customizable is Mender.
With Mo's second question, they're asking how customizable is Mender in terms of integrations with existing infrastructures and workflows.
Okay, now Mo, that is an awesome question. If we happen to meet sometime, I owe you a drink. Because no, seriously.
So Mo isn't a plant. He wasn't planted here by Mender.
Nope, actually, I have no idea who Mo is. Hi, Mo, nice to meet you. No, seriously, that's one of the cool things. We've been talking a little bit about the backend, and I'm gonna be evil now. Stuff that whatever can sell stuff has to be good looking. That's how you get people to insert coins. That's why we have a dashboard that gives you all the stats and access to devices and whatever. But the magic is that whatever this dashboard can do, like pull the device stats, create a deployment to ship out software, upload artifacts, manage devices, whatever, all of the API that this dashboard uses is documented and meant to be used. So if you feel like customizing whatever of the Mender dashboard, you can do so. You can also rip it out and never look at it again, because we talked about pipelines. Let's talk about CI pipelines. You create something, your software, in your CI pipeline, and you can have a fully automated upload into the Mender pipeline. And example, you could have a GitHub bot or action, excuse me, where you just like comment, okay, Mender go, then it runs off, triggers the API to deploy the resulting artifact out to your fleet, whatever. So the customizability, especially concerning the backend and integrating it with other workflows, I would say is like excellent. We have examples in the documentation how to interact with it from JavaScript, Java, Python, even Bash. I mean, we are providing HTTP curl examples on how to manage your software device software with Bash. How nerdy is that?
It's always nice when you've got simple endpoints that you can do that with, because it makes it so easy to integrate with just about anything, right?
Yes. That's the point about it.
So I'm going to take the next one here, and this is from a new person asking. Again, I'm going to try to get your name here right, but Pipilia Kuldeep, and Pipilia Kuldeep asks, "What could
That's Johnny
be?"
Depp.
That's Johnny. Oh, yeah, that is Johnny Depp. There's a picture of Johnny Depp. Yeah. What could the memory footprint of creating container environments on? What could be the memory footprint of creating container environments on an IoT device? So I'm going to try to interpret this, and Pipilia, please tell me if I'm getting this wrong, but what is the memory footprint when creating container environments on an IoT device?
So maybe the question is, what is the Mender overhead on top of whatever your application is?
There you go. That sounds like a better articulated question.
Yeah, the Mender overhead is we want to have systemd usually. So if you want to get around systemd, then you are up for some, let's say, manual integration, but it's technically doable. So we want to have systemd, and the client, which is actually just being rewritten to C++. We are shipping it basically now. The new iteration is about 4.5 megabytes, give or take a couple of 100K. So that's the stuff you need to reserve on your device. And inside, so Mender can also be used to ship containers back and forth, but I think that is not the question here. So I agree that the interpretation probably is like, what does Mender impose as resource consumption on the device? And it is a generic Linux environment as of today, and about 4.5 or 5 megabytes of storage. I would say that's it.
And this kind of, I think this dives a little deeper into this question, or at least elaborates on something slightly different from Madhu Keshwar. How much additional memory and time overhead does it take for the entire process to complete its OTA kind of update? I think at minimum. I feel like this is a hard question because there's so many different things you can send OTA, right? But yeah, I mean, what does I guess maybe you could, there's another question I have that we might want to dive into after. Before, do you want to try hitting this one?
I can try to give it a very quick like categorization, and then I'd refer to for further discussion maybe on our discussion board or whatever. So completion of OTA at a minimum, I would say. So assumption here is that OTA means a full root file system update, because there's a lot of flexibility here. And so the additional time and memory overhead, time I can tell you, because I can tell you how fast your connection and your storage are. But the memory overhead is 0, because we can stream directly to the inactive partition. So it does not work like download everything like a gigabyte blob, storage, have the additional storage for it, and then copy it over somewhere. No, if you are using a Mender artifacted OTA file system update, then it works like this. The client says, okay, is there any update? Yes, check signature, whatever, something, and then streams the content of the file system directly from the storage backend to the inactive partition. So time, I can tell you because it depends on the device. Memory overhead, basically zero.
That's great. I think that hopefully that answered your question, Madhu. I want to take this because we don't have that much time left, and I really want to take this to a developer space. All right, so we may have developers. It looks like we have developers watching who might want to experience Mender for the first time. So if someone was going to Mender.io or your hub where the community kind of congregate and communicate, what might that developer experience look like for the first time? I may be an experienced software developer, but I've never used Mender. So, maybe you could walk me through that journey real quick.
Yeah. So the experience looks like this. You are directed to a sign up page where you can create your Mender account. So you get your dashboard. And from there on, there is a wizard that basically takes you through the onboarding of your favorite device, and your favorite device is our favorite device because you have to use a Raspberry Pi 3 or 4. Sorry that we're not using like a big plethora of devices. So the developer onboarding experience is like that. Make sure you have a Raspberry Pi 3 or 4 and sign up and follow the process. The process means flash an SD card, make sure it boots, and from there on, you get a snippet that you run on the device, which downloads, installs the Mender client and everything, and it will show up straight in your dashboard. If you leave the preparation of the Raspberry Pi aside, then I'd say the pure process basically takes like 5 to 10 minutes. As we all know, copying software onto an SD card, putting it in, powering everything up, and logging in and all that stuff takes a couple of minutes now and then. So I'd say you can complete all of the onboarding process in less than 45 minutes, including rolling out your first update to a Raspberry Pi.
And so that's kind of like your hello world of sorts, is this Raspberry Pi example. By the way, your documentation it looks very nice. I love this. It's, there you go. Prepare a Raspberry Pi device. So the documentation on Mender, which is docs.mender.io, is a very nice place to start. It looks like.
Yeah. Thank you very much.
Yeah. Oh, did you put some of this together?
Partially. Let's say I'm usually more involved in using it and then heckling people if it doesn't work.
Very nice. Very cool. I think that if anyone is interested in checking out Mender, just head on over to Mender.io, and it looks like from the Mender website, you basically have access to everything. You can go into their docs area. There's some very well written blogs in there. It looks like the blogs are not only written from folks at Mender, but from people in your ecosystem, which is really nice. You can join their community, which is hub.mender.io. And at hub.mender.io, it looks like there's a nice discussion forum there, and it looks quite interactive. Several thousands of topics in some of these, and so it looks like people are being engaging over there. And then, of course, if you'd like to explore their offerings, you can go check out their different products. You can look at their different services, and of course, explore more of the resources other than what I went over right now, including tutorials, product briefs, video libraries, all that kind of stuff. So that's pretty cool. Very nice website as well. Is there anything else you'd like to cover while we're here? I'm sorry?
I'll pass it on. We have an excellent design team.
Yeah, I like it. Is there anything else you'd like to cover about the website while I'm kind of showcasing it here?
About the website?
Any other places you'd like to go look at?
I think the one thing that is a little bit outstanding about Mender is that Michael mentioned building Ubuntu, and Mender is a little bit like Ubuntu, and therefore what is Mender's canonical? And Mender's canonical is Northern Tech. So I don't know if we have a direct link here. It's northern.tech straight away, which is like the mother company and Mender's main it's Mender's back technology. And I think, as you say, Mender, the thing that I want to point out here is that this company is in Oslo, and it has a very, very special and strong culture, which is why I'm sitting here in southern Germany and advocating for them, because their team spirit and the culture and making things work, and everybody thriving to make something valuable that is just extremely incredible. And it might sound strange that I'm here advocating for a technical product, and then I'm saying you, okay, the culture is special, but that's really how I feel, and that's the crazy part of being on this journey.
And you mentioned being open source earlier, and I think that's really just a part of open source culture in general, isn't it? Like the people and the culture is every bit as important as the technology and the implementation of it itself.
Yes, I mean, that's what put me on this journey. I told you I've been doing this for decades by now, and all of my journey has been basically fueled by open source. When I started out with those old devices, and then Linux and embedded Linux really put me on this track. And I think I can take like 30 seconds here to big shout out to the embedded build systems like PTX, Buildroot, and primarily the Yocto project, which I'm also very involved with, because the world by now runs on embedded software, and it runs on embedded open source software like
Big
Linux.
time.
And this is a field of technology that is completely underrated, and the public is completely unaware of it actually existing. So my shout out here is, yes, we need people like Mender or similar projects and products to make this work, but there is so much more beyond it, and you as developers probably know about it. But it's also take it out to the people you talk to, your families and friends, and make them aware that the world does not just magically happen to work, but there are people that make it work. And it's not just Netflix that runs your daily lives. It actually, it is your fridge, and it is your telephone, and it is your gas station that make your daily lives work. And you would be really, really scared if those go away. And I mean, we all know Linux by now runs power stations. What would you do without a power station?
Yeah, no, everything. It is actually kind of interesting. You say that. You say, what would we do if all of a sudden this stuff stopped existing? I'm like, I'm going to grab my backpack with my little tent and head out to the woods. Goodbye electricity. Goodbye internet. But yeah, so we are getting to the top of the hour here. And I really do want to thank you, Josef, for joining us. It's been a pleasure talking with you. And I feel like we could go for a whole other hour. So I would like to ask you that, if you are free at some point, in the 2024 just started, if Mender has any cool stuff happening in the rest of the year, please do let us know. We'd love to have you come back for kind of a follow-up with Mender, and maybe we could even like showcase a little demo of the dashboard, get you on, open up the dashboard, show us like what the product looks like. I think that would be a lot of fun.
Yeah, definitely. Cool. So for stuff that is coming up, FOSDEM is next weekend. So if you actually are happening to be in that space, I will be there. Yeah, exactly. So I will be there. Just hit me up, say hello, curse me, praise me. I'm grateful for everybody who says hello. We'll find a place somewhere on the campus and have a beer or whatever drink you desire. Besides that, embedded world, where I actually collect my ARM swag usually. So that is also coming up, and of course the various open source and embedded Linux conferences. We'll find a way to meet again, either virtually. Thank you for having me here, and I'll be absolutely delighted to join you again for whatever opportunity, because it's been really a pleasant conversation. And of course, I'm really easy to find. If you Google Josef Holzmayr, eventually plus Linux, then you'll instantly find me and just say hello.
And there you go. You can go stalk him on his LinkedIn as well. So and he'll know though. He'll know. But yeah, Michael, anything last from you before we close this out?
I have 2 shameless plugs, if it's okay that I do too. The first one, because you were talking about, needing a Raspberry Pi to get started, and they have been a little bit hard to come by recently, but you can go over to avh.arm.com. That's the ARM Virtual Hardware Project. Like somebody was anticipating me saying this. You can get a virtual Raspberry Pi 4 there to test out Mender with. I did this when I was working on learning paths for things like AWS Greengrass. So it works great for that kind of thing. You can do a whole mock deployment there. And Josef, if we could get a learning path for using Mender to deploy to Raspberry Pis using AVH that kind of mimics those that I've already written, I would love to get with you to see if we can work together on that.
Ooh, that would be really cool, because basically, you have the whole process that you have written out there for your kind of hello world on Mender that can be done in a virtual space. And that might be pretty interesting for developers to get their hands dirty with Mender. But, if they don't have a Raspberry Pi, they can still do it virtually. So that might be interesting to see.
All right. And my second shameless plug is, of course, our Discord server. Josef, please join that. Anybody else watching, please join that. And we do have a FOSDEM 2024 channel under the events section for people who are attending there to post updates, pictures, videos, anything from the show. I know we've got some of our friends from Ampere who are going to be going there. I've got a lot of personal friends who are going there, running the community dev room there. So I hope you have fun there. And I do look forward to seeing some pictures from it.
Awesome.
I promise.
Yeah. Okay, cool. Well, we are at the top of the hour, so I think it is time to close this out. Josef, I want to thank you once again for being a part of this, spending this whole hour with us. And we do look forward to having you again. Michael, my amazing co-host over here, you did great. We did great. I think it was a fun episode, and thank you so much for being here as well. And everyone
in the audience too for all those great questions that we got.
Yeah, that's true. Let's just name them off real quick. Mo, Pipalaya, Jason for commenting that this podcast is like Little City. I hope that's
Liddy City, I think it is.
Oh, Liddy City. There you go. Liddy City. That's good.
What is that?
I think that just means like this is lit. Like it's good. I'm hoping. Okay. Yes. But yeah, anyways, thank you all so much. You could have spent this hour doing so many other things, and you spent it here with us. So we appreciate you for that. And once again, we will be back next week, every single Thursday at 5 p.m. UTC. We look forward to seeing you here. Our guests next week is going to be Lenaro, and we're going to be talking about Lenaro Forge, I believe, right? That's the next week. Okay, so then what's next week? What do we got? Can we pull it up?
Yeah, I have to pull up the list.
If not, what we're going to do is we're going to post it in the description below so that you can go check it out. Either way, you'll see it on the ARM Software Developers YouTube channel. So make sure you go check that out. You'll see it there as coming up next. And you can register or set your reminders now. Of course, we do implore you to subscribe to the ARM Software Developer YouTube channel. And if you enjoyed this stream, please make sure you thumbs it up. So thank you all very much. Hope you have a nice week, a great weekend, and we'll see you next week on Innovation Coffee, Thursday, 5 p.m. Thank you all. Josef, take care, buddy.
Yeah,
everyone.
Right,
thanks.
Bye.
Bye.